Patty Simpson with Simpson Math. In this video, we're going to graph a polynomial with irrational roots. Here we have a polynomial. It is a fourth degree polynomial. Notice that it's not in descending order, so let's rewrite it first to begin with in descending order. So I have f of x equals x to the fourth minus 10x squared plus 25. When we're ready to graph our polynomials, the first thing we like to do is look at its end behavior. And we see that the leading coefficient on this polynomial is a 1. What's important about that 1 is the fact that it is positive. When our leading coefficient is positive, it tells us that it's going to rise on the right. If it had been negative, it would tell us that it would fall on the right. Then we look at the degree of the polynomial, which we said it was a fourth degree polynomial. What we care about that for is that it is even. When our degree is even, we have same end behavior. So since it was rising on the right, it also will rise on the left. So the leading coefficient tells me what it's doing on the right, and the degree of the polynomial tells me what's happening on the left. Then we also know, because of the degree is 4, that we are going to expect to see 3 terms in our function. And because that degree is 4, we will have 4 roots, 4 linear factors, 4 x-intercepts. Well, some of those x-intercepts may be double roots, but we'll have 4 roots for sure. Then we can give a sketch where it rises on the right, it falls on the left, and we have 3 turns. So, no, it rises on the left, sorry, and it has 3 turns. So 1, 2, 3 turns. 1, 2, 3 turns. In the end, I should expect my polynomial to look something like that. The next piece that I'm going to look for is the y-intercept. My y-intercept, along that where the graph intersects the y-axis. And to find the y-intercept, I need to just find where x is equal to 0, because x is 0 on that y-axis. So I'm just going to substitute in to my function 0 everywhere I see an x. So 0 to the 4th power minus 10 times 0 squared plus 25. This is 0, that's 0, and it just leaves me with a 25. So I know that I have a y-intercept at 0, 25. Then my next step is to find the x-intercepts. So I'm going to find the x-intercept, or where the graph intersects the x-axis. And in order to do that, I know that my y is always 0 on that x-axis. So I'm just going to substitute in for y. Remember, f of x is the same as y. So I'm just going to substitute in that 0 for y and then solve. I have here the function and set equal to 0, and what we do when we have the degree is higher than 1 is we factor it in order to find those x-intercepts. So here I have 3 terms. I'm going to use my AC method to help me factor it. My A here is 1, my C is 25, so I'm looking for factors of 25 that add to 10, and if we look at 5 times 5, that adds to 10. I need it to be a negative 10, so if I do a negative 5 and a negative 5, that still multiplies to be a positive 25, but it adds to be that negative 10. So then I can rewrite my terms, 5x squared minus 5x squared plus 25, using those 2 factors that I've just found. I now have 4 terms, so I can group them. I'm going to look at the first grouping, x to the 4th minus x squared. I'm going to factor out the greatest common factor of x squared, and it leaves me with x squared minus 5. In this case, I'm going to look at the back 2 now, group those 2, look at them, factor out their greatest common factor. And their greatest common factor is a minus 5. And it leaves me with an x squared. Because this was a minus, it changes that sign to minus 5. So when I factor it, I end up, look, they match. You've got an x squared and an x squared. That's always great when they match. We can factor that out so that we have x squared minus 5 times x squared minus 5. Now the whole time this has been equal to 0, so I have two numbers that are multiplying together to equal 0. Not quite done. I want this down to linear factors. So I'm going to multiply again to get this down to, or I'm going to factor again to get this down to linear factors. Notice that I have two terms, so I look for a difference of squares. Now 5 there is not a perfect square, but we can still use the difference of squares to help us to factor this. We just take and write two parentheses, put a plus and a minus, take the square root of the first one and the square root of that back one. So I'm just going to take the square root of 5. I'm going to do the same thing on this side because that is exactly the same. Plus and minus, square root of x and square root of 5. And all that's equal to 0. I now have it down to linear factors. We said there were going to be 4 of them, and sure enough, there are 4 linear factors. I have 4 numbers multiplying together to equal 0. One of them has to be 0. Perhaps it's this guy, or this one, or this one, or this one. So I just set all of them equal to 0, and now I solve so that x is equal to a negative square root of 5. X is equal to positive square root of 5. Add square root of 5 to both sides. Subtract square root of 5 from both sides. So that I end up with a negative square root of 5. And here I have a positive square root of 5. So my x-intercepts, this is my x value, negative square root of 5. My y value is 0. Here, square root of 5, 0. There, negative square root of 5, 0. And here, square root of 5, 0. Notice the multiplicity of these. The multiplicity, this negative square root of 5, shows up 2 times. So the multiplicity of the negative square root of 5 is 2. This square root of 5 also shows up 2 times. So the multiplicity of the square root of 5 is also 2. Remember that when our multiplicity is even, and in both cases these are even, when our multiplicity is even, that tells me that it's going to turn around at that point. So at both of these points, it's going to turn around. It's going to hit that point and turn around. At both the negative square root of 5, 0, and square root of 5, 0. We say this is a double root because its multiplicity is 2. And this is a double root because its multiplicity is 2. Now that I've found all my pieces, I'm now going to graph this function. So here on a coordinate plane, I'm going to graph this function. Let's start by graphing these irrational roots of square root of 5, negative square root of 5, and square root of 5. In a previous video, we looked at how we could approximate those. We know that the square root of 4 is 2, and we know the square root of 9 is 3. This square root of 5 is somewhere in between 2 and 3. It's closer to the square root of 4 than it is to the square root of 9. So it's going to be closer to 2 than it is to 3. Approximately 2.2, something like that. So I know that I can, when I graph it, I'm going to go over 2 and a little bit. So when I graph these, I go over 1, 2, and a little bit for this square root of 5, 0. And I go backwards 2 and a little bit for a negative square root of 5. So 1, 2, and a little bit. So there are my x-intercepts. My y-intercept is at 0, 25. Maybe I should count by 5s. 5, 10, 15, 20, 25. So 0, 25. Now I'm going to graph it, and I know on the right it's going to rise. I know on the left it's going to rise. And I know that it has to go through that point. The multiplicity tells me at this point it's going to turn at a negative square root of 5. So it hits this point and it turns around and comes back up to my y-intercept. Then somewhere it turns around. Remember, in this class we don't know where that turning point is. We can be more accurate by substituting in 1, 2, -1, and -2 for x to find out the y value, but we'll learn that turning point in calculus. So here it turns around somewhere, it comes back down and hits this x-intercept, and when it hits that x-intercept, we know again, because the multiplicity is 2 and it's even, we know at the square root of 5, it's also going to turn around. So there is our function graphed, and it looks like our original sketch said it was going to look like. And there we have graphed our polynomial with irrational roots. 0, 25 is our y-intercept. So there is that fourth degree polynomial with irrational roots graphed completely. Math Made Simple is Simpson Math. Thanks for watching.